Okay, let's get started, ladies and gentlemen. Who can tell me the distributive property contains the operation of blank with addition or subtraction? Who can give me the answer to number 1 vocabulary review? Fatima, you want to take a guess? Multiplication is correct, yes. Okay, so you can use distribution property to do mental math. And so number 2, who has the problem rewritten using distributive property? How'd you break it down? I don't want to know the answer. I want to know how you may use distribution property. Christian?
So I did 15, and then I did 15 and then times 40.
Okay, that's one way to do it, yes. 15 times 40. Okay, did somebody have another way, though? Abu?
I did, I said 15 times 8.
15 times 8. Okay, that's one way to do it. Let me show you this way because I feel like this relates more to how the book wants you to do some of this. Do you see what I just did? All right, isn't 15 the same as 10 plus 5? Right? Okay, and then 8 times 10 is pretty easy, right? What's 8 times 10? 800, right? And then 5 is half of 10, so we can figure out easily what's 8 times 5? 400. So do you guys see how mentally you can do that really quickly? And then that's an addition sign between what's in the parentheses. So what's 800 plus 400? Okay. Do you see how that works? Yep. Go ahead. So any question about the first problem? Now, let's take a look at the next problem, because this one's a little bit interesting. If you found this one interesting, I got another one I think you guys might be interested in, because this is another technique you'll use. You're not always just going to have plus. You can have, Fatima? Okay, 9 times 2 for 18, that's one way, but I think there's probably an even easier way. Take a look at this. Isn't 18 the same as 20 minus 2, right? And then we know 10 times 75 is what? 750. Well, 20 is double 10, so what's 1,500? And then 20 and 2 are related by a power of 10, right? So if this is 1,500, 75 times 20, then this is 75 times 2 is going to be 150. Do you guys? Okay. Some of you guys automatically do some of this stuff because when we're working things out in class, I can tell that you're mentally doing this. Okay. So you did 2 times 9, but distribution property is add or subtract and then multiply. So let's make sure we have that ironed out. Yep. Oh, you're right. And actually, I did over here, so I apologize. So that should be a subtraction. That was another typo. Let me see if I can fix that really quickly. Okay. So the next one over here. So I did subtract it, 1350. You guys see how we did that? Any question about number 3? Okay. So these are whole numbers, but if we look down here, they can help us out with decimal numbers too. This is really, really close to what? 1 whole. So can I think of it that way? Again, we're using subtraction, so hopefully I remember to put subtraction in there too. All right, so if we look at this, 78 times 1 is easy, right? It's just going to be what? 78. And then 78 times 1/10, well, what are we going to do with my decimal? I'm going to move it. So what is that going to be? 7.8, or 7 8/10. All right, now we can mentally do that. 78 minus 7 8/10.
Please
Right.
pardon the interruption.
Very
Teachers
good.
and students, please be aware that Mr. Pierre will be out of the building for a few hours, so do not send any students to him because he won't be here. If you need anything, make sure it's an emergency for technical issues. Other than that, we don't have anyone to help right now, so just hold on
Okay,
until he gets back.
so that was another typo. I fixed it in the post editing. All right, So 27 times 1 and 1/10. That's really close to what again? 1. So we can do my distribution probably this way, right? Do you see how we did that? Okay. So we know 27 times 1 is, and then 27 times 1/10, 2 and 7/10. And then we can add these. What do we get back? 29 7/10. Okay. Pretty cool way to do it mentally, right? All right. Moving along. Here we go. All right, what you'll learn, to find and estimate the percent of a number. Why learn this? You can use a percent of a number to help you analyze statistics, such as how many students in each grade participate in school activities. Suppose your choir has 44 students, and 25% of the students are in the 8th grade. Then 25% of 44 is the number of 8th graders in the choir. To find 25% of 44, you can write 25% as a decimal or as a fraction, then multiply by 44. So we're trying to find the percentage of an amount. Okay, in this case, we have 44 students, and we're trying to find 25% of that group, so we know how many 8th graders are in the choir. Okay, so I'm going to have an example you're going to work out. I just want to walk you through this first. Okay, so this is the example in the book, and they actually gave you this answer, so let's really quickly review this. So the first method they talk about is writing percents as a decimal. And if you guys remember, do you guys remember my trick I try to get you guys to remember? If we're writing a percent as a decimal, we're moving the decimal away from the percent sign, and we're dropping the percent sign. Do you guys remember that? So the percent sign's here. There's no decimal here, but we know where the decimal would be if there was one, right? It's between the 5 and the percent sign. And how many places are we going to move that percent sign? 2. So if I move it over 2, 1, 2, that's why it ends up here as a decimal. Do you guys understand? Okay. So if I write this as a decimal and then I can multiply it by 44, I'll know how many 8th graders I have, and here it is. Be careful. Some of you guys are forgetting to move the decimal place at the end of your multiplication. Okay? Do you guys see why I moved it 2 places? Why did I move it 2 places? Timothy? Because what? No, I'm talking about my multiplication right here. Do you see why I moved it in the end? Do you see right here on the board why I moved it here? Well, we're trying to figure out where my decimal ends up when I take the product of these two numbers. If you notice, the decimal is already at the end here, right, for 44. How many places is the decimal in here for the first number? Twice. So I take the sum of how many places I have, and at the end, I move it in 2 places. Got it? So do you guys understand why it's 11? So we have 11 students that are in the 8th grade that are in the choir. Got it? Now that's method 1. Method 2 says, hey, rewrite the percent as a fraction. Well, remember percent means what?
1.
Per 100 or divide by 100. So 25% I wrote as 25 divided by 100. And then we know how to simplify that fraction by a factor of what? What goes in the numerator and the denominator? 25. 25. So 25 divided by 25 is what? 1. And then 100 divided by 25 is what? 4. So now we have this fraction 1/4, right? So here we go. I have 1/4, and I have to multiply by 44, but I have to turn 44 into a fraction, right? So do you see why I turned 44 into a fraction where I put it over 1 over here? Okay, and then notice what happens to my 4s. What's going to happen to these 4s over here? They cancel out, because I thought of 44 as 11 times 4, right? Isn't 44 the same as 11 times 4? And so we can cross-cancel, and what we get is 1 times 11, 11, and then we end up with 1 in the bottom. 11 over 1 is just 11. So you see that we get the same result? Okay. Now what I want you guys to do, that was my example for you. What I'd like for you guys to do is try the 2 methods. Try the 2 methods here. And I even give you the fraction here, and I give you the decimal here, just to kind of get you guys going. Yeah.
So like, can you do it like when you go, okay, So 79% is a part of 100, right? And there are 3/4 of 100 to make 70.
Right. For now, right, 3 out of 4, right? That would make $1.
So could you like do it by like doing 140 divided by 4 then times 3?
Well, there's a couple ways to do this, and I guess it's important that we understand the two methods they're showing you at this point, okay? Because there's usually more than one way to do it. And so they're showing you two methods, but there's other ways to think about this, right? Just like yesterday's lesson, I showed you that you didn't necessarily have to think about it as fractions. You could just think about it as how many places I moved in the decimal because I'm dividing or multiplying by a power of 10. I gave you a trick to know which way to move the decimal. So to answer your question, there's other methods, yes. Okay, so who can walk me through the first example? Who found the percent as a decimal by multiplying? Abu, what'd you get?
I got 105.
You got 105? Okay. So I'm going to verify what Abu just did. And actually, I color-coded the zeros that you added. So 0 times 75 gave me these 3 zeros. I got to add a 0 before I multiply the 4. That gave me 300. I got to add 2 zeros before I multiply the 1. That gave me 75. When you add it up, here's what we got. Because I have 2 places here, I moved it in, I get 105. Does everybody understand that? I'm reviewing that because there's still a handful of you guys that are struggling with that still. Okay. Now, the two methods, choose the one that works, that gets you the answer fastest. Do you understand? When you're taking a quiz or a test, use good time management. So here we go. Let's take a look at this problem. So it's 3/4. What am I going to multiply 3/4 to? Class?
140.
Well, I got a fraction, so what's 140 need to be written as? 140 over 1. So here's what we got. And if you notice, I can think about 140 as 4 times 35, right? And then my 4's cancel. And so 35 times 3 gives me 105 over 1, which is 105. Okay, Abu?
You could have done 2 times 70.
2 times 7. Why would I have multiplied 2 times 70?
And yeah, and then 4 would be 2 times 2.
Where are you getting 70 from? So I'm trying to get people to understand, like, we're going to work with the number 75. I need to rewrite that as a fraction, 75% as a fraction, right? And then I'm going to multiply it to the quantity that they gave you. So, Abu, does your method get you to the same place?
Yes.
So I still need to figure out, where did you get your 70 from? Because you took 140 and you divide by 2, and so you have 2 in the denominator. Is that what happens?
I split 4 into 2 times 2, and then I split 140.
Okay, so what you did was you canceled a factor of 2, and you got 70 here, but you're left with a factor of 2 in the denominator, right? So this would be 2 down here, and this would be 70 up here, right? So then 70 times 3 would be 210, but then you still got to divide by 2, which would give you 105. Okay, so you just cross-cancel a little differently. Okay, Logan, you had a question?
So what if one of the factors doesn't cross-cancel?
Then you have to keep it, like the 3 didn't cancel out. I had to keep it and multiply across. Does that make sense? So cross-canceling, what that does is it saves you a little bit of work, because I could have multiplied 3 times 140 and then divided that by 4. Do you understand? But if I saw that I have a factor of 4, I don't need to multiply that factor of 4 here and then undo it by dividing by a factor. Do you understand? That's why. So Abu's correct, but his had a few more steps involved. Okay, if I see that I can cancel 2 things in the numerator and the denominator, then that saves me a little bit of work.
What if I got the same answer when I did it in Maryland?
We're going to have many ways to get to the same answer. So let's move along. Now, I want you to take a look. You can use mental math with some percents. 100% of a number, that means the whole number, all of it, right? So 100% of 190 is 190. these are things you should be able to do mentally, readily, okay? 50% is half of a number, right? So 50% of 190, I don't think that's correct, is it? Yep, that is 95. All right, and then 10% of a number is 1/10 of the number. Okay, so you're just going to move your decimal in one place, right? And we did that in the warm-up. You saw that we used that in the warm-up. So 10% of 190 is 19. 1% of a number, if you take a look, if I moved it in one place for 10%, how many places did I move for 1%? Two places, right? So 1, 2. I got 1 and 9/10 for 190. Okay? So let's take a look at this. And if you notice, we're using distribution property. And that's why we had that in the warm-up. So 11%, and this is the example in the book, you could think about as 10 plus 1%, right? Isn't 10 plus 1% 11%? Now we can set up our distribution property problem. Here we go. If you want to think about it this way, that's fine. And then multiply it out. But that kind of goes in line with what we showed up top about moving the decimal. Okay, so if you showed me this and then worked it out, I'm okay with that. Or if you showed me this and worked it out, I'm okay with that too. Just so you understand mentally what's going on. So what happens to my decimal if I multiply by 10%? Move it how many places? One place. If I'm multiplying by 1%, how many places am I moving it? 2 places. Okay, so here we go over here. Boom. Here's what it looks like over here. I'm going to move it 2 places. Here, again, moving it 2 places for 1% or 100ths, and moving it 1 place for 10% or 1/10. And so the final answer, we can add this in mentally, right? 84 plus 8 and 4/10. That's pretty easy to do. Well, 4 plus 8 is what? 12. So that means 84 plus 8 is going to be 92, and then 4/10, right? Okay, so do you see how we're doing that mentally? All right. And then same deal for this. Okay, so any question about distribution property and how we're going to use that to mentally? Now, if it says mentally solve, you still need to show the steps. Because just from what I've seen with the project on distribution property, some of you still don't have that connection made yet. Okay, so we're doing a reteach now. I want to make sure you guys understand it. Show your steps. Okay, because when you do understand distribution property, it is a useful tool to mentally make calculations. I use it pretty regularly whenever I would go out to dinner. They say like a reasonable tip is 15%, right? So 10% is pretty easy to do, right? So if I had a $22 bill, right, what would 15% be? Well, 10% of $22 is what? $2.20, right? And then I need the 5%. 5% of $22, well, what's half of 10%? $2.20. What's half of $2.20? $1.10. So 15% would be $3.30, right? Do you see how you can mentally crank out like a tip for when you go out to dinner? Or there's a number of situations where you might want to just mentally get the number. You don't have a calculator ready, your phone's dead or whatever. Okay? So now here's what I want you guys to do. I got 2 examples right here, or 1 example right here, sorry. I want you to mentally, I want you to set up the distribution property, and I want you to solve this. And whether you write it out as decimals, that's fine, or just leave it as a percent, that's fine. Set that up. Okay, Thomas, can you walk me through this? What happens? What do I get? Tell me how you got there.
So I got 50% minus 10%.
Oh, nice. That's a good one. I like that. I like your method better than my method. So you did 50% minus 10%. That was better than mine. I did 20% plus 20%. Because I was thinking 10% is easy, so double that, right? But you get the same answer. I like yours better. Did you guys hear his example? 50 minus 10? Because 50 is pretty easy because you can just do half. And then 10 is pretty easy because that's just move the decimal place. Right? All right. I'm going to go ahead and show mine. And then we're going to go ahead and do Thomas's. So Thomas said for his, he wanted to use instead, and I'll do yours in green, or actually blue. He wanted to do 2,400 times 50% minus 10%. Okay? And then, Thomas, what did you get when you got 50% of 2,400?
I got 1,200.
1,200? That's an easy one to calculate. Then we got to subtract 10%. What's 10% of 2,400? 240. Okay? And then when we subtract that, what do we get? 960. Nice. I like that. Okay, so just to show for consistency of what I did above, you can show this with decimals too. Okay, group. Okay, does everyone understand the two methods? Are we good? All right. And I think this illustrates quite nicely that you can set up distribution property a couple different ways. And for me, 20% plus 20%, that made sense for me. But I actually kind of, now that I heard Thomas's, I think that's actually even easier than my example. Do you guys understand? So it's kind of whatever you mentally figure out at the moment. Like, okay, I know this, so I'm going to set it up this way. Okay, are we good? All right. And it goes back to what Christian was making the point. There are many ways to set up and solve math problems. Okay, many ways. Just like there's probably, you could probably come up with 15 different ways to get home, right, from the school, right? And you might have an idea of which is a better way to get home, which is a faster way to get home. But you might have 15 different ways. Sometimes you might have to use another way, or sometimes you use a way that makes more sense to you. Did you guys see a lot of ice on the road this morning? So I had to kind of go and weave around some of it. I don't know if some pipes burst or something, but one of the streets that was hilly had like just a sheet of ice on it. So I had to go like a completely different way. So it was not the fastest way, but it got me here. All right, so let's go ahead. The lesson is almost done. Estimating percents. So I want you to take a look at this. Now we want to talk about estimating percents. All right, so you can use compatible numbers to estimate a percent. Do you guys remember compatible numbers earlier this year? Okay, they're numbers that we can easily compute mentally. So 32%, that's about a third, right? And 912, well, that's pretty close to 900. And so if we were to calculate that, remember we can multiply, we can calculate the percent of something by multiplying the fraction, right? Remember that was the first example we talked about. So here's what we got, right? And then we see that we can cancel something out, right? Doesn't 903, don't they have a factor in common? They have what factor in common? 3. So 3 would cancel out of here, and 3 would cancel out of here, and what I'd be left with is 300 over 1, or 300. Okay? And so your candidate received about 300 votes. All right, so now I want you to see if you can use the same trick for these examples right here. Three, estimate, come up with an approximate. And then I'm showing you right here what I did up above. So see if you can work these out. Work these out on paper so you have them. Mentally, you're going to forget about it as soon as you walk out of this classroom. Have it in your notes. Write it out. We'll go over questions after we go over the solutions. I need you to try for now. Try your best right now. When you've given me an estimate for these three, put your pencils down. When we're done with this, we're almost finished with the lesson. So for this first problem, what did you get for 24%? About how much is that as a fraction? Logan?
24% is 25%, so I have to.
Nice. So I don't know if you heard what she said. 24% is about 25%, and that's about a quarter or a fourth, right? And then 238 is pretty close to a compatible number, and we got a fourth, right? So what's a compatible number that is very close to 238? Ola? 250. 250. Is that compatible with 4? What did you come up with? 25? 225. I think we have a better one that's even closer. How about this? 240, right? Isn't 240 and 4? Those are really close, right? Okay. So now we know how to find this, right? Can't we take a fourth times 24? And what's that give us back? We know that like mentally, right? What is it? 60. Okay, so here's what we have. Gives us 60 over 1, or 60. Does everybody understand? Okay, so who can give me this next one? 82% of 747. So 82%, what is that close to? 80, right? And then 747, what is that close to? That's a factor of 80. 750? I heard 750. Did I get 750? That's what I agree. So 8/10, 750. 750 is nice because 50 ends in 0, and I can get rid of the 0 by that 10, right? So here's what we got. And that is a typo. That should be a 10. Okay. Sorry about that. Okay, 8/10 times 750. What happens to 750 and 10 when we cross cancel? It becomes what? What's the numerator become over here? Just becomes 75. And then 75 times 8, what is that? 600. It's 600. So we get 600 over 1. Yep. You did 4/5. Okay, that would work. 4/5. All right. This one, I feel like this one was a little more straightforward. What is 19% really close to? What fraction? 20%, right? So that means we have a fraction. What fraction is do we use for 20%? 1/5. All right, and then 473, what can we say 473 is really close to? I would just use 500. Okay, and so that's super easy. 1/5 times 500 over 1, what's that going to give me back? 100, which is 100 over 1, which is just 100. Any questions about estimating with distribution with compatible numbers? Are we good? Questions, class? Okay, we're just about done. Let's wrap it up. Use distributive property to get these problems to find 58% of 50, 8% of 400, 48% of 121, and 10% of 70. I thought this one, I felt like, why would I even bother with distribution property for this one? But I went ahead and did something just because that's what they wanted you to use. So go ahead, work these out really quickly. Who can tell me what would I use? What's the sum or difference of a set of numbers that would give me something nice and easy to calculate? Fatima. 50. If I did 50, what would I do? 50 and what? What other number would I use? 50 and what gives me 58? 50 and 58 gives me 108. I want 50 plus what number to give me 58? 50 plus 8. So here we go. Okay, are we good? Isn't 58% 50 plus 8%? Okay. So what is 50 times 50%? What's 50% of 50? 25. And then 8% of 50. Well, 50 and 8%. Remember, we're moving. 5 times 8 is what? 40. We know 8% is a tenth, is in the tenths place, so I move my decimal in, right? So 40, move it in one place, 4. We get 29. Okay, any questions? The 4, well, 8% times 50%, right? Well, what's 1 times 50%? 1% of 50%. 1% of 50%, what is that? It's 5. What? No, 1% of 50%. 0.5. So 0.5, multiply that by 8. 0.5 multiplied 2 is 1. 0.5 multiplied by 3 is 1.5. Multiplied by 4 is 2, right? Okay. All right. So you might have had an easier way to come up with it. That was just one way I chose. Just like what we did with Thomas's, there's more than one way. All right. 8% of 400, how would I rewrite that? That one I feel like I can use one that's really, really easy. What two numbers can give me, if I take the sum or difference, gives me 8%? Timothy in the back. 10 minus 8, nice. I did the same thing, or 10 minus 2 gives me 8%, right? Is that what you meant? 10 minus 2 gives me 8%. And what's 400 times 10%? Timothy? 40. And what's 400 times 2%? What's 1% of 400? 1% of 400 is 4. So 2% of 400 would be, if 1% is 4, what's 2%? If 1% is 4, what's 2%? 8. There we go. What's that going to be? 32%. Did anybody have a different method and they came up with 32? What'd you use? What two numbers? You use 2 and 6%? It's not easier because 6% is a little bit challenging to calculate. Is that why? All right. So we try to use numbers that we can mentally calculate. So you have to be careful about the ones that you use. Okay, so who's got one for 48 and 120, 48% of 121? Who's got that one? What's 48% really, really close to? There's a percentage that we can use that is really, really close to. 50%. So how would I write that distribution property to use 50%? I heard it. Who said it? 50% minus 2%, right? And now you should be able to calculate that now. Shh, there's way too much talking going on. Calculate that out. 50%'s easy. Can somebody tell me what 50% of 121 is? When we finish this. What's 50% of 121? 60.5. What's 1% of 121? 1.21. And so 2% would be 1.21 plus 1.21, right, which was 2.42. So here's what we got. And then when we subtract that, that's what we get. This one's super easy. I think you guys know how to do this mentally without distribution property, but I went ahead and worked it out. Here's what we got. And I just wanted to show you it's 7. All right. Now, write an expression and estimate each answer. Remember what we did earlier? What's the percentage close to? 20. So what's the fraction we'd use? 1/5. What's 63 really close to? 60. So let's go ahead and use that. Here's what we got. 60 divided by 5 is 12. 73%, what's that really close to? 75%. And 75% is what? 3/4. Okay, we want to use fractions that we can easily calculate. And then 80, that one's pretty easy. Here's what we got. 80 and 4, that cancels. That gives me 20. So 20 times 3 is 60. 15%, I didn't think that was a really obvious one, so I'll go and show it to you. 39 is close to what? 40. 3/20, right? Because 5% would be what? 1/20, right? So 15% would be 3/20. All right. What is 12% of 100? What's 12% of 100? 12. So what's n% of 100? N. Very good. Okay. And then the last one, I'll just go ahead and read this to you. When would you use a decimal to find a percent of a number? When would you use a fraction instead of a decimal? So this is just a sample answer. This is what the book gives. You would probably use a fraction when the percent can be written as a fraction that is compatible with the other number. You would use a decimal for all, that should be an A, for all other cases. Okay? Any questions? And that is the lesson for today. Yes.